In the previous video, I gave you two scenarios. The first one is your dad is already traveling at 8 meters per second at time equals 0. Okay, and then the second scenario is where he is stationary at time equals 0, and then he would put his foot on the accelerator. That means his acceleration. Let's say his acceleration is 2 meters per second squared. Okay, again, don't worry about this bit. So his acceleration is 2 meters per second squared. What that means is every second his speed will increase by 2 each time. So look, 1 second, his speed. Remember, this is the speed time graph. So his speed increases by 2. Remember, he's stationary here. Up here, he's not stationary. At time equals 0, he's not stationary. That's why at time equals... So you can imagine he started down here, and he's already increasing his speed. So by the time he gets here, it's already going at 8 meters per second. Down here, he is at rest. So his speed is 0 here, okay? And then, so at time equals 0, his speed will be 0. He then puts his foot on the pedal. So here, his acceleration will increase. His speed will increase. So when he puts his foot on the pedal, his acceleration is, let's say, 2 meters per second. So his speed time graph will look like this. And I said that if ever you want to know the distance traveled, then work out the area underneath the graph. Okay, so let's say in this scenario here, how far would he have traveled after 4 seconds? So here you would work out the area underneath the graph. Okay, you would work this out. Now let's look at the units here. Let's remember this 8 here represents his speed. So 8 meters per second. So speed is written as this. Okay, the minute you see this, you can imagine it as this. M. So at the moment it's M times 1 over S, because from indices we can see that the minute you have a power of a minus something, immediately jump to this. So now you've got M. So you've got meters. Remember, speed is given as meters times 1 over second. Okay, so and again, if you don't understand this bit, then watch one of the earlier videos why the unit of speed is given by this. Okay, so hang on. If you get the height here, which is speed, by the way, speed is written, well, this can be multiplied to the top. So speed is like meters over second. Okay, and now look at this here. So this height here is speed. It's meters over seconds. Okay, because that's a unit here. The height here is meters over second. Now, when you times this thing here, it is time. So you're timesing another time. The unit of time is seconds. So here, this gets multiplied to the top. So in effect, you have meters times, you have meters, which is this bit here, times times seconds divided by seconds. So here these two are the same, they kill off each other, leaving you meters. So when you work out the area underneath this, it basically represents meters, and meters is a measure of distance. So when you get the speed and then you times the time, the overall answer would be in meters. That's why well, if you get this thing here, if you get the unit here, just look at the unit. The unit of this is 8 meters per second. So you can imagine the unit being like this, and then you times seconds here. This distance is in effect the across here represents the time in seconds. So you're in effect multiplying another seconds. Okay, so this gets multiplied to the top, giving you m seconds, and then divided by seconds. So that's why when you work out the area underneath here, the unit of it will be meters. Meters happens to be distance. Okay, now look at this here. Now we are saying that your dad is accelerating at 2 meters per second squared. Okay, so now, so his speed time graph will look like this. Now, here's the thing: if you if you work out the gradient of the speed time graph, that would give you his acceleration. Okay, look, because we're saying his acceleration is 2 meters per second. What that means is, well, he has a gradient of 2 basically. So here he would have, after 1 second his speed will increase by 2. After another second, his speed will increase by another 2. After another second, his speed will increase by another 2. So when you have an acceleration of 2 meters per second squared, it basically means the gradient of the speed time graph will be 2. Okay, so another way of looking at it is that when you're given the speed time graph, if you work out the gradient of this here, it gives you the acceleration. So from here to here, you see there's no acceleration because he's always going at 8 meters per second. So up here, your dad sitting in the car going 8 meters per second. He's not accelerating. He's just going at a constant speed. So the acceleration here, or the gradient here, is 0. There is no acceleration. Whereas down here, from 0 to 4 here, there's an acceleration, and the gradient here is 2. So the gradient here is 2. His acceleration is also 2. So if his acceleration is 4 meters per second squared, the gradient here will also be 4. So my point is that when you're given the speed time graph, if you work out the gradient, it will represent the acceleration. So the gradient here is 2. The gradient here is 0. So there's no acceleration here. Whereas here there's an acceleration of 2. Now, why is the unit of acceleration meters per second squared? Now, we said that if you work out the gradient of this, it represents the acceleration. Okay, so let's work out the gradient here. Now, this height here, well, the gradient is always height divided by the across. Okay, now the height is meters per second, because but by the way, it's given like this, but I'm going to visualize it as this. Okay, same thing. Okay, to the power of -1. I can visualize the speed as this. Okay, let's start again. Hang on. If the acceleration is given by the gradient of this slope. Now, if you work out the gradient, you would get the height divided by the across. Now, the unit of the height in this case would be meters over seconds. Now, so the up and down here is really meters over seconds. Okay, so now you've got to get the up and down divided by the cross. The across here is actually in seconds. Okay, so in effect you would get this divided by this. Now so what that means is you would get this, which is m over s, and then divided by s, by seconds here. Okay, now when you divide a fraction, it gets multiplied to the bottom. So this here becomes meters over s squared, because here you've got seconds here, and then it gets multiplied to the bottom. That's why it becomes m over s squared. Now, the minute you get this, you can visualize it as this: meters times 1 over s to the power of 2. Okay. Sorry. Hang on. Hang on. So here this becomes this. Sorry. Hang on. This, you see, this here we can visualize it as this. So take the m out. Okay. So in effect, hang on. Let me start again. Sorry. So here we are here at the moment. Okay. Now this thing here you can visualize as this: m times 1 over s squared. So at the moment it's meters and then times 1 over s this. Now from indices, the minute you get 1 over this, you can go the other way. So this thing here becomes meters, and then this thing here is actually seconds to the power of 2. Okay, so it's this times this. Now this is why the acceleration is given by meters per second squared, and it has this minus 1, to the power of minus 2, because it gets it gets multiplied to the bottom. That's why it becomes seconds to the power of minus 2. Let me just reiterate. Again, if you want to know the acceleration, you would get you would work out the gradient, which is the up and down divided by the cross. Now the up and down is speed. Okay, the unit of speed is this, or this. These two are actually the same, just written differently. Now the acceleration would be the up and down here divided by the across. This across here is measured in seconds. Now the acceleration or the gradient of this slope is given by this, which is m over 2, and then you've got to divide it by this, which is given in seconds, divided by this. Okay, now this gets multiplied to the bottom because you're dividing. You've got a fraction divided. Well, when you divide, you multiply it to the bottom. So this here becomes m over s to the power of 2. Okay, now this here is the same as this, meters to the power of minus 2. Now that's why acceleration is measured in meters per second squared. The way you pronounce it is meters per second squared, but it's to the power of minus 2. Okay, that's because, well, the gradient of this speed time graph is given by the height divided by this. So so the acceleration is given by this. Okay.